This is the screen capture for example 5 of section 4.7. We're going to compose some trig functions and inverse trig functions, but in a different way than we have been in previous examples. This time we're going to use an algebraic expression because we don't know any values. So example 5 says compose each of the 6 basic trig functions with inverse sine of x and reduce the composite function to an algebraic expression involving no trig functions. So in other words, we're going to only have x's in here, an algebraic expression. You can't say the inverse sine of x equals something with trig in it. So when they tell us that the inverse sine of x, they give us this expression. This expression is saying there is an angle out there whose sine is x. They are essentially saying the sine of theta is x. So they gave us the inverse, and we can decode it by switching the input and the output and using sine. So I'm going to put theta somewhere in a right triangle here, and I'm going to make theta's sine x. So theta's opposite will be x, and its hypotenuse is 1. Opposite over hypotenuse, x over 1. Theta's sine is x. Now, using Pythagorean theorem, I can say that a squared plus x squared equals 1 squared, or a squared plus b squared equals c squared. And I can get a squared equals 1 minus x squared. So a is going to be the square root of 1 minus x squared. We don't need to worry about plus or minus here because distance can only be positive. So now I'm going to plug in, on my third side, I'm going to label that 1 minus x squared. Now, I have enough information about this triangle, so if I know what x is, I can tell you what each of these sides are, and therefore tell you what the sine of this angle is, whose inverse is x. Or I could tell you the cosine of the inverse sine of x, or the tangent of the inverse sine of x. Remember, this inverse sine is looking for an angle. Well, we have set up that angle in this triangle so that each of its sides are labeled for an algebraic expression that will tell the distance or the length of each of these sides. So the sine of the inverse sine of x, which, by the way, the inverse sine of x is theta. We've labeled that. So the sine of theta is the opposite over hypotenuse, x. The cosine of the angle whose sine is x, or the cosine of theta, is the adjacent over hypotenuse. So square root 1 minus x squared. The tangent of the angle whose sine is x, or the tangent of theta, is the opposite over adjacent, so x over square root 1 minus x squared. I know you're not usually allowed to leave a square root in the denominator, but with an algebraic expression like this, I don't want to worry about that so much. I'm just worried about the fact that you have the algebraic expression correct. The cosecant of the angle whose sine is x, or the cosecant of what we are calling theta, is the hypotenuse over opposite, so that would be 1 over x, or the reciprocal of the sine of theta. Secant will be the reciprocal of cosine, so the secant of theta will be 1 over square root 1 minus x squared. And then cotangent will be adjacent over opposite, or the reciprocal of tangent, so square root, cotangent theta equals the square root of 1 minus x squared over x. Now, this problem gave you only the inverse sine of x as your initial information, and we had to decode the triangle, set it up with algebraic expressions for the length of each side, using what we know about inverse trig and Pythagorean theorem. Now 47 gives you, your now try problem, 47 gives you basically just one of these 6 conclusions we came to after setting up the triangle. So you're going to set up this triangle so that the inverse tangent of x is theta. Or, in other words, the tangent of theta is x. So I'm going to call theta, I don't know, I'll name it this angle. So the opposite over adjacent, or the tangent, has to be x. So opposite over adjacent. Now I'm going to use a little Pythagorean theorem. X squared plus 1 squared equals c squared, which means c is going to be the square root of x squared plus 1. There's nothing you can do to reduce that. So the hypotenuse here is x squared plus 1. Now the one composition our problem is trying to ask, or is asking us for, is the sine of the angle whose tangent is x. So the sine of this angle we're calling theta is the opposite over hypotenuse. So the answer here is x over square root x squared plus 1.